So similar triangles is the next activity here, lesson 3. So there were 2 requirements for a polygon, for a pair of polygons to be similar. Okay. What were the 2 requirements for a polygon, for polygons to be similar? Nice and loud, somebody.
Corresponding angles must be congruent and corresponding angles must be proportional.
So corresponding angles have to be congruent and corresponding sides have to be proportional. Okay? So the same is true for triangles because triangles are polygons. Okay? But you actually don't need to prove that all the angles are corresponding, or all the corresponding angles are congruent. You don't need to show that all the corresponding sides are proportional for a triangle because there's actually some theorems that apply here. So we're gonna apply these theorems. The 3 theorems are, well, first off we have AA. Now recall this is an acronym. It stands for angle angle. When we did triangle congruence, we had 5 different ways of proving triangles congruent. Recall SAS, right, SSS, AAS, hypotenuse leg, and what, ASA or whatever, right? So we had all those ways of proving triangles congruent. Well, there's 3 ways of proving triangles similar. The first one is AA. It stands for angle angle. If 2 angles in a triangle, that's the AA, are congruent, then the 2 to the 2 angles in another triangle, then the triangles are similar. So all we need is a pair of triangles in each triangle congruent, or angles in each triangle congruent, and we can show the triangles are similar. Because if you think about it, if 2 of the angles are congruent, then that means the third one must also be congruent to each other. And so all 3 angles are equal, and believe it or not, that means that all the sides are proportional. Okay, we're not going to go through a proof on that, but it's true. The next one is SAS. Don't get this confused with side angle side from congruence. It's similar, but it's not the same. In this case, instead of if 2 sides are congruent for their congruence, if 2 sides are proportional to the corresponding sides of another triangle, and the angles between the 2 sides are congruent, then the triangles are similar. Okay, so for congruence, the sides had to be congruent. It had to be side congruent to side, angle congruent to angle, side congruent to side. For similarity, it has to be side proportional to side, angle congruent to angle, side proportional to side. And then finally, we have SSS, which is similar again to congruence. Side, side, side. If all 3 pairs of corresponding sides are similar, or are proportional, then the triangles are similar. Okay? So we're going to look at one of each example. First with AA, says show why these 2 triangles are similar. So these angles are congruent. How do we know they're congruent? They're vertical angles. How else do we know they're congruent? They've got the congruent marks, right? And so angle ABE is congruent to angle DBC. Are there any other angles here that we know are congruent? And D, how do we know they're congruent? And they've got the congruency marks, so they must be congruent. And so the fact that we have 2 congruent angles means that these triangles are similar by angle by AA. Next example of SAS. Show why these 2 triangles are similar. So for side angle side, we need to show first that the sides are proportional. So we need to show that the ratio of 21 to 7, so this side to this side, is equal to the ratio of this side to this side. So 15 over 5. So 21 divided by 7 is 3. 15 divided by 5 is 3. So the sides are proportional. And then, so we have side proportional to side, side proportional to side. We need angle congruent to angle. So we have angle R congruent to angle U. They're both 110 degrees. And so we would say similar by SAS. Now notice if, let's say instead of 5, let's say this were 10. Could we now say the triangles are similar by SAS? Why not? Yeah, the sides aren't proportional. So if the sides aren't proportional, we simply say, well, they're not similar. There's no magic trick to it. Okay, just say not similar. Okay. And then the last example is for side, side, side. It says show why these triangles are similar and give the scale factor of the first to the second triangle. So to show they're similar, since we're given the three sides, we know nothing about angles, right? We can't use AA because we don't know any angles. We can't use SAS because we don't know any angles. We have to use side, side, side. So we need to show that the ratio of 4 to 6, so notice I'm taking corresponding sides, is equal to 8 to what? Okay. And then which must be equal to 6 to 9. And so now we just reduce these fractions. 4 over 6 reduces to 2/3. And remember, you can use your calculator for reducing the fractions. And you can also change them to decimals. If the decimals are exactly the same, then that's fine. So 2/3 equals 8 over 12 reduces to 2/3, and 6 over 9 reduces to 2/3. And so since all three ratios here are equal, then we can say similar by SSS. Now, if any of these were not equal, just one of them, then we would say not similar. Okay. Now it says give the scale factor of the first to the second. So our scale factor, first to the second. So we pick one pair of corresponding sides, which we already had up here, and we write that ratio. So 4 over 6. And we've reduced that ratio to get the scale factor. 4 over 6 reduces to 2/3. These triangles are similar by side, 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 and the scale factor is 2/3. Yeah, you just need one pair of sides to get it to the scale factor. To show that they're proportional, you need to check all three. But then if they're all the same, that fraction that you get is the scale factor, assuming that you're putting it in the right order. So you just want to go back and double check, because on the assignment part, it says give the scale factor if possible. You just want to make sure you're doing the first to the second. So you'll put the first one over the second. Okay?